All right. Hi, everyone. Today, in this video at least, we're going to be looking at Module 4, Tools of Discovery, Older Brain Structures, and the Limbic System. So continuing on with the biology that basically makes up our brain, as well as our nervous system and everything like that. Today's we're looking specifically at the older parts of the brain. So the parts that are located closer to the center of the brain. A little smaller portion compared to the newer parts, the like prefrontal cortex and things like that. We'll look at those in the following modules. So yeah, we're going to start off with kind of looking at some of the tools that are used for doing these studies, and then looking at the various structures and what they do essentially. So hopefully go fairly quickly, and we'll keep on moving. So another reminder: make sure you do the quiz and listen for the little random facts as we go, so that you can do that quiz with no problems. Okay. With that, let's get going. So, slide 2, and as always, again, you can also follow the PowerPoint, D2L, download, print off. Okay, here we go. Here we go. Slide 2, the tools of discovery, having our head examined, part 1. New generation of neural map makers. So today we have a lot more tools. Since the 1950s, 1960s, we've developed a lot more tools that allow us to basically see the brain in action. Okay. In the past, we were limited, like as far as studying the brain, we were pretty much limited to somebody dying and then pulling their brain out, looking at the brain, and then kind of dissecting it and seeing what we got. Nowadays, we can actually see them while they're alive, which is much more useful, and see how the activity moves throughout the brain. So these are some of the tools we use. One is selectively lesion and observe brain function. So what is a lesion? Okay, not a legion, like a legion of soldiers, but a lesion. A lesion is essentially just damaging part of the brain, either intentionally or accidentally. Okay. So it could be anything from, like, somebody smacks their head and there is damage in the brain, and then they can study that person and see how it affects them. They can intentionally go in and destroy parts of the brain, which can happen, again, either intentionally, like if you're doing experiments on certain animals and things like that, or even in some cases, some surgeries. They might go in to remove a tumor or to stop seizures or different things like that. And in doing so, they unintentionally damage the brain in order to fix the disease or the issue. Okay. But this actually gives us a lot of information, because we can then see how the brain, like, what does the person do? How do they overcome that damage? And also, how does the person change, right? If a certain part of the brain is damaged and all of a sudden they can't see, or they lose their sense of smell, or they can't move their left hand for some reason, or their right hand, or whatever, okay, or the personality shifts, or they suddenly can't recognize faces. All of these things can be seen when we look at the brain and see, okay, what part of the brain was damaged, and that part of the brain is likely connected to the given thing, right? An example, and I'll probably use this example again later. There was a man living in Washington State, so Northwest in the United States, who was originally from Japan. He was obviously fluent in Japanese because he spoke Japanese from home, but he had learned English when he moved to America. When he was in his, I believe, early 60s, he suffered a stroke, and when they revived him, he seemed pretty fine, except for he had lost the ability to speak Japanese. He could speak English fine, but his ability to speak Japanese had disappeared. So he actually had to relearn Japanese in order to communicate with his family. But that showed us basically that the brain, even in languages, doesn't always use exactly the same parts for the same language, right? So if you're multilingual, it can actually spread out and diversify the parts of the brain that are used with that. Okay, selective lesions, that's basically what they're looking at there. So in this case, usually when they're studying like on rats and things, they'll go through and intentionally damage one portion and then see what happens in the rat. Another way is electrically, chemically, or magnetically stimulating brain parts and note the effects. You basically go in and make the brain fire off and then see what happens. Okay. And then detect an electrical pulse to a single neuron, which we have tools that actually allow us to do that now. We can trace one neuron's path basically and how it fires into the other neurons. Okay. So view color representations of the brain energy consumption. So we can also see, when certain activities occur, where does the brain light up and things like that. Okay. Next slide, slide 3, the tools of discovery, having our head examined, part 2. These are some of the tools that we utilize in doing this research. So one is an EEG, and also you can find more information on this on page 52. There's a table that kind of gives you the breakdown of this. So be aware of these tools and kind of what they do and how you can use them. Okay, but the EEG, or an electroencephalogram, is an amplified recording of the waves of electrical activity sweeping across the brain's surface. So basically, this is when you see somebody that looks like they're wearing like a shower cap, shower cap with all the cables coming off. And that is essentially just reading the electrical impulses that are traveling over the brain. Okay. This has actually been used quite a bit in like sleep studies and things, kind of figuring out what our patterns of sleep are. It actually accidentally was the tool that was used to discover that there are different stages of sleep as far as what our brain is doing with different brain waves and things like that. The guy, it was actually a grad student. He had an EEG machine. He brought it home, and he was working on it, trying to fix it back in the, I think it was in the 60s when he did this. And to test it, he stuck the cap on his son's head while his son was asleep to see if it was working. Turned the machine on, and the brain waves were totally different than anything they'd ever seen. And he was like, something must be wrong. So he reset it, did it again, and exactly the same thing happened. He woke his son up, and suddenly the brain waves entered back into what they were as normal, okay, like a normal waking person. So with that machine, they're able to discover basically the different stages of sleep that our brain goes through. We'll look at that when we look at sleep later in the semester. An MEG, or sorry, my notes, magnetoencephalography. Okay, sorry, apologize for you can read the word, it's in here. Okay. Stumble over it like me, or if you're better at Latin and Greek, you might do activity sweeping across. Sorry, that's EEG. Brain imaging technique that measures magnetic fields from the brain's neural electrical activity. Okay. So again, same kind of a thing, looking at the waves that are occurring within it. A PET, or positron emission tomography scan, is a visual display of brain activity that detects where a radioactive form of glucose. So basically, you'll enter in some radioactive sugar as it travels through your body, utilizing a PET scan. Okay, so it's not exactly the healthiest thing for the individual, but it can be useful in finding different issues and things within the individual's brain. But then you can also see where basically that energy goes in the brain as a person is doing a specific task. So that way they can see what parts of the brain are going to be using that. An MRI, or magnetic resonance imaging. So this is going to be like what we have here in the image on this slide. You can actually also see this image on page 52 of the book. But essentially, it's a still shot of the brain in that given moment, and you can thus then compare and contrast the different aspects there. Okay. In this image, actually, just for example, in image A, we have a healthy individual, basically. This is going to be an average person's brain. Okay. In image B, we have the enlarged ventricles, the fluid-filled brain region. This is a person who actually is struggling with schizophrenia. So different brain structure. We don't, like, again, schizophrenia is kind of like a broad umbrella term that covers a kind of a relatively large gamut of issues. But one thing is they found that oftentimes people who suffer from schizophrenia have more fluid within the center of the brain. Okay, interesting stuff. Okay. But an MRI is basically what the tool is going to be used to determine that, kind of look at the brain in that moment. An fMRI, or a functional MRI, is a technique for revealing blood flow and therefore the brain activity by comparing successive MRI scans. So it's going to basically taking a bunch of pictures and producing a movie, essentially, of the brain in action. So this doesn't only just show the brain structure, but it actually shows the brain functioning, from a moment to moment, right? So you can actually see what's occurring, what's changing from point A to point B, and like they might be doing a certain activity or different things, or having certain thoughts, or listening to certain things, and seeing how the brain reacts to that. Okay. These are some of the useful tools. We have also some newer tools. So slide 4, tools of discovery, having our head examined, part 3. I'm going to drop down real quick to the current research efforts. So Europe's Human Brain Project, the PsycEncode, and Human Connectome Project are some additional tools that are basically in the experimental phase. where they're looking at some different ways that they can look at how the brain functions. There's more information on that on page 53. The new activities of neuromarketing, neurolaw, neuropolitics, neurotheology, these are all areas that basically that are getting opened up as we're learning how the brain works. So you might have heard, like, for example, neurotheology. You might have heard like the God spot. There are a couple of psychologists that are basically looking at when a person experiences a spiritual experiencing a spiritual experience. Okay, is there a part of the brain that basically fires off? Short answer is no. There's a lot of parts of the brain. When a person experiences like an ecstasy, let's say, or their deep meditation, it actually has a pretty significant impact on a lot of different parts of the brain. So is the person experiencing a spiritual thing or a physical thing? That we still don't know. There's no actual answer to that. But that's going to be some of those kinds of questions and different fields that this are. The neuromarketing and neurolaw are going to be connected to the fact that we now have this information available. What is legally allowed to be done with that? So this is opening up a whole new area of potentially invasive marketing and things like that. And so, like, what are you allowed to do, not allowed to do, and all these things. Okay. Yeah, that's it. Okay, let's look at random fact number 1. Okay, random fact number 1, violin bows are commonly made from horsehair. And that's actually one of the best materials you can use for bows, for a violin and a cello, and for bow, like, big double basses and all that kind of stuff. And interestingly enough, they found that the best horsehair seems to come from Mongolia in most cases. So, random fact. Okay. So yeah, violin bows, horsehair. There you go. Next slide. Slide 5. Older brain structure, part 1. Older brain structures function without any conscious effort. So we're looking at the actual brain now. We're moving away from the tools that we use to actually looking at the brain. The older parts of the brain basically it doesn't require you to think in the conscious sense of that. Okay, this is going to be your subconscious. These are generally going to be the parts that keep your body going, right? The fact that you don't have to think like beat heart every time you want it to beat, or like like a blonde joke where the blonde has the headphones on and then takes them off and falls over dead, and they're like, "What was she doing?" They listen to it and it says, "Breathe in, breathe out, breathe in, breathe out." Okay, we don't have to think about it, right? The brain just does it. For the most part, that's how these older structures are going to work, which is why we share these in common with simpler life forms. Okay, you might even hear some people talk about like the reptile brain or primate brain or things like that. These are going to be those aspects that are connected to those other critters, right? Doesn't take any kind of conscious thought whatsoever. The brain stem is the oldest part and central brain core, automatic survival functions, and crossover points. So this is going to be the very center right here at the back of your head. If you feel that little soft spot at the base of your skull, that is essentially where the brain stem is. We'll look at that a little bit more here in a second, but there's an image coming up of that, and we can talk about it more in depth. So yeah, but it's right there at the base. Essentially, this is that point that if it breaks, you die, because you have just, if it gets destroyed, you have essentially turned off the connection from the brain and the rest of the body. Everything pretty much goes through the brainstem. So you essentially, it's a relatively quick death if that gets destroyed. But yeah, that is connected to our automatic survival functions, your heart beating, your breathing, your digestive system working. All of those things are going to be connected to the brain stem. Okay. The medulla is the brain stem's base, heartbeat, and breathing. Okay, that's exactly what that one's set for. But if you, like I said, we'll show you an image here in a second. You can also find an image of the brain on, let me see, what do we got? On page 54 and 55, actually, we have some decent images of the brain. 54, you have the image of the brainstem with the medulla at the very bottom. But then you also have the thalamus and the reticular formations and pons connected there. Okay, we'll talk about those in a minute. Okay. Let's see, slide 6. I already talked about the medulla, yes. Slide 6, old brain structures, part 2. The thalamus. So the thalamus is the brain sensory control center. Okay, so it's basically its primary function. Um, it's at the top of the brainstem. It directs messages to the cortex sensory receiving areas and transmit replies to the cerebellum and the medulla. Basically, it's the post office of the messaging that comes through all of your senses. Okay. I'm trying to think if there's anything else I want to talk about that. So yeah, that's essentially its primary role with that. Reticular formation, again, you can see this on page 54 if you want to see the structures there. It's a nerve network that travels through the brainstem into the thalamus and controls arousal. So this is going to be, remember we talked about yesterday, the different states of arousal, of stress versus relax, right? So the sympathetic and parasympathetic nervous systems, or states of being. This is going to be where the reticular formation basically kicks in. Okay. It's judging the information coming in through the thalamus on as far as looking at, like, are we experiencing something that is worth being aroused by, positive or negative, and then what should the body kick into gear for it? Okay. And then the cerebellum, the little brain at the brainstem rear, processes sensory input, coordinates voluntary movement, output, and balance, and enables nonverbal learning and memory. It does a lot of work, right? But it literally looks like a little brain just right here in the very back of the skull. Okay. You get smacked in the back of the head really hard, and that can paralyze you, even though everything is technically working correctly. Basically, you're functionally paralyzed. Your body might move, but you can't voluntarily do so. It also sometimes, if that gets damaged, it can make it where you lose certain senses. Okay, so including your potentially your sense of balance. There have been issues. There's been a couple people around the world that have like different virus things that attack the cerebellum specifically, and they'll lose the ability to walk unconsciously. So they can consciously stand. They learn to do this. It's quite a process, but they can learn to consciously stand and consciously walk. But they literally have to think about every movement. You're intentionally coordinating all of your muscles to hold yourself still. What we don't realize is just how many muscles are engaged constantly when we're just standing still. Your brain is basically constantly making small shifts and adjustments given where your body's at in its balance points. Okay. So yeah, that's going to be all of that. Let's see. Next random fact. Let's see. Number 2, people who post their fitness routines on social media are statistically more likely to have psychological problems. So, interesting stuff. If you see people posting their fitness stuff, it's not a guarantee, right? There's a correlation, not a causation, right? So it correlates. People who do this a lot oftentimes also have other issues psychologically. Okay. Keeping on moving. Slide 7, the limbic system, part 1. And you can see this on page 55. It's a neural system. It's located below the cerebral hemispheres. And it regulates emotions and drives. Okay. This is where, if you use Freudian terminology, this is where the id lives, right? That part that says, I want the cookie. Okay. It's going to be what's controlling, like when you start to feel thirsty, it's the thing that makes you seek out a drink of water to quench that thirst. When you start to feel hungry, it makes you seek out food to get rid of that hunger. If it gets damaged, a lot of times those drives disappear. You basically lose all motivation to do anything when it gets damaged in certain areas. But it's also going to be the part that helps regulate emotions, so your ups and downs and all those kinds of things. In some cases, people who struggle with certain mood disorders, including depression, for some people, it can be actually connected to this neural system right here. Okay. So the amygdala, hippocampus, pituitary glands, and hypothalamus, something goes a little bit wacky in there, or isn't working how it technically should be. Okay. We'll dig into these here in just a second. All right, third random fact. There is a underwater version of rugby called underwater rugby. Not that inventive, but it looks interesting. 6-on-6, all underwater. It's a full contact sport. We try to move a ball into the other team's goal, but yeah, fully underwater. There's no breathing apparatus or anything. It's all free diving where you're holding your breath. Okay, next slide. Limbic system part 2. The structures in here, we have the amygdala. The amygdala are the two bean-sized neural clusters, and they specifically control the emotions. So they're going to be, is this an image of the amygdala? I think it is. Let me just double check. No, that's actually the hypothalamus. Okay, the amygdala, it's going to be located just right above, in the center of the brain, right above the brainstem, basically. Yeah, basically that's going to be where all of your emotional control originates from. So it's going to be how we, to some extent, how we interpret the information coming in, right? You feel arousal. I talked about this a little bit on the module 3. You feel arousal, and you know, it could be aroused from a bear charging you or your crush coming down the hall towards you. And both of those things are going to cause arousal. Biologically, it looks the same. How you interpret that is basically how we experience all of the vast array of emotions that we have. And the amygdala is going to be where that interpretation occurs, as far as we can tell. Okay. Hypothalamus, the neural system below the thalamus, which is what hypothalamus means basically, directs maintenance activities, helps guide the endocrine system via the pituitary gland. Emotion and reward is where this is going to be placed in. Okay. So again, pituitary gland and all these, right? They help guide what's going on inside the body, and the pituitary gland is going to be sending signals to other glands that then produce different hormones. The rewards, this is also where the reward center of the brain, right? You do something that's that very good, you get a cookie, and then your brain associates this action with that cookie, and so therefore you're more likely to do that action again. The conditioning process, which we're going to look at later, that is going to be connected to the hypothalamus. Okay. So it's where we see certain actions getting punished. We're like, we don't want to do that anymore. Certain action getting rewarded, we want to continue doing that, and that's going to be some of those things there. Okay. Hippocampus, neural center located in the limbic system, helps process explicit or conscious memories of facts and events. This is also where it goes for storage. Okay. So something happens, and you have that, you know, that memory of that camping trip when you were 10 years old, and such happened, or old Uncle, you know, Harry did this or that, whatever. Those are going to be there, or the fact that you know that 2 + 2 = 4. That's going to be connected to the hippocampus. So yeah, very important part of the brain. Obviously, all of these parts of the brain are very important. If they get damaged, our quality of life deteriorates pretty darn quickly. So yeah, away we go. Slide 9. This is an image you can also find on page 57. Just kind of shows you where everything is located in these different parts of the old structures of the brain. So the blue sections are the cerebral cortex. The kind of purpley colors are going to be the limbic system, and the pinky colors are the brainstem. Okay. We're going to look into the cerebral cortex later in the next modules, but that's where we really get our humanness from, is from our cerebral cortex. That's where all the complex thinking and the complex functions of being human essentially occur. Okay. Last random fact: the human eye is sensitive enough to see a candle flame from 30 miles away if it's unobstructed. So it could be, if it's dark 30 miles away and there's nothing between you and it, the eye can pick up that little beacon of light that far away. Okay. And that is basically this module in a nutshell. So that was a little quicker. That's good. Some things to be aware of, like in the book, it mentions has professional football damaged players' brains. Contact sports and things can actually be getting smacked in the head over and over again. Even if it's micro concussions, it adds up over time. And what they found is that people who play contact sports, specifically people who play impact sports, football, hockey, lacrosse, and those kinds of games, rugby, all of those sports, boxing and martial arts and all that kind of stuff, you run a much higher risk of experiencing brain damage in the long run. So the effects might not be evident immediately, but over time, it adds up, basically. So interesting stuff. All right. So yeah, with that, don't forget to do the quiz. Got the 4 random facts in there. Make sure that you're checking that out before the end of the week. And I think that's it. If you have any questions about this or the other material, make sure to message me or hit me up in the discussions, and I'll do everything I can to get back to you right away and get your questions answered. So yeah, until next time, we'll be looking at Module 5, where we are looking at the cerebral cortex, the more complicated human parts of the brain, if you will, that make us as complex as we are. So until then, have a wonderful day. Good luck with everything, and I will see you all.